Hello everyone, I welcome you all for the second PUC practical session. In this session, we will be learning an experiment of a focal length of a convex lens. The aim of this experiment is the determination of focal length of a convex lens by plotting a graph of u versus v, where this u is the object distance, v is the image distance. Now in this experiment, we will be determining the focal length of a convex lens. So we need to understand what is a focal length. Imagine we have a convex lens, this is a convex lens and this is the principal axis, and say a parallel beam of light is incident on this convex lens. Okay, a parallel beam of light is incident on this convex lens. So this parallel beam of light, after refraction through the lens, it will be converging to a one point like this. Okay, so it will be converging to this point like this. Okay, so this point of convergence is termed as F, which is nothing but a focus. This is called as a principal focus. A principal focus is a point on the principal axis such that all the rays after refraction converges to that particular point. Therefore, the distance from this lens to the focus is called as a focal length f. So, in this experiment, we will be determining this focal length f. First, we need to get the value of approximate focal length, that is by distant object method. Now, how do you measure this approximate focal length? Imagine we have a tree here, and somewhere here I have placed a convex lens. So the rays from this tree are incident parallelly on this convex lens like this. Okay, so they are incident parallelly on this convex lens, and the rays are going to converge to a focus and they are forming an image here which is an inverted image of this tree like this. It will form a inverted image of this tree at this particular point. See, this is the object which is lying at a very far distance. So I will consider this distance as object distance as infinity. Okay, the object is at infinity. That is why the rays are parallel to each other. So the image is going to form at the focus. Therefore, the image distance is equal to f. So image is formed at the focus means this distance, the distance from the convex lens to the image is the image distance which is forming at the focus. Therefore, this will be equal to the focal length. So we have a thin lens formula, 1 by f is equal to 1 by v minus of 1 by u. If I substitute 1 by f is equal to 1 by v minus of 1 by u, u is infinity, that is why f will be equal to v. That is how we get this v is equal to f. Okay, so when the object is at a far distance, the rays emitting from this object are a parallel beam of light. When the parallel beam of light is incident on a convex lens, it forms an image at the focus which is an inverted image. By measuring this distance, what we can measure? We can measure the focal length which is given by this formula. Okay, so we got the focal length of the lens. Next, what we need to do? Now let us look at the principle of this experiment. The principle of the experiment says the object distance must be greater than the focal length of the convex lens to get a real and inverted image. That is the first point. How do you understand this one? So if I place an object somewhere here means this is object distance. The distance from the lens to the object is object distance. This object distance is more than a focal length, correct? If this is a focal length, this object distance is more than a focal length. So when I place the object here, what happens is a ray of light is incident parallelly to this and it will be refracted in this direction, and one more ray which is refracted along the optical center will be going like this, so that an inverted image, a real and inverted image is going to form. So in order to get that real and inverted image, we must place the object beyond this f, or the object distance u should be greater than the focal length. Then only we get the real image. Next, when the object distance is equal to twice the focal length of the convex lens, then the image distance is equal to twice the focal length. How do you understand this one? Well, let us place the object exactly at 2f. Okay. Now a parallel ray of light is incident on this convex lens and it will be refracted through the focus, and one more ray which is going through this optical center, that will be refracted in this way. Correct? Yeah. This is an image which is formed at the 2f. So a real and inverted image which is formed at 2f. So this image is at a distance which is equal to 2 times the focal length or 2 times the focus. So when the object distance u is equal to 2f, then the image distance is also equal to 2f. So by this convention we can measure the focal length. So using that diagram we can understand the second point. So when the object distance is equal to the twice the focal length of the convex lens, then the image distance is also equal to the twice the focal length. For the different values of object distance and image distance, when you plot a graph, so how do you plot the graph? The object distance should be considered as negative because it is towards the left side of the lens, and the image distance is considered as positive because it is towards the right side. So while plotting a graph of image distance versus object distance, how do you get the graph? Along the positive y-axis, we should consider image distance because image distance is positive in this case, and along the negative x-axis, we should consider the object distance. Okay, fine. So after plotting this, how does the graph looks like? The graph looks like this. We get a curve like this. So for this curve, when you plot, so in this curve, somewhere at this point, what happens is the object distance and image distance are same. Say if 2f, if I place the object at 2f, then image is also going to form at 2f. Therefore, at this particular point, the object distance and image distance are equal. Say this is O, this is A, and this is B. Okay. So I know that this OA is equal to 2f and this OB is also equal to 2f. So when you add OA plus OB, what you will get is 2f plus 2f, and OA plus OB will be equal to 4f, or f is equal to OA plus OB by 4. So to find the focal length using this graph, what we have to do is we have to find this OA and then we have to find this OB. So by adding OA and OB, divide it by 4, you will get the focal length. Well, now let us start performing the experiment. First, let us look at the apparatus required for this experiment. So here we have a convex lens. You can observe this is a convex lens, and the convex lens is mounted on the V-shaped lens holder. This is mounted on this, and we need a bulb along with. So here you can see an object pin. Behind this pin we have a light source. Okay. Next, here this one is a screen where the image is going to form, and we need a meter scale. Okay. So these are the apparatus required for this experiment. Let us start performing the experiment now. So here we have a light source. In front of the light source we have an object pin. Correct. How to take the object distance? The distance from the center of the lens to the object pin. So here we have an object pin just in front of the source. So this distance is taken as object distance u. Then how to find the image distance? Image distance is the distance from the center of the lens to the image form. The image is going to form on the surface of the screen. Therefore, from center of the lens to the surface of the front surface of the screen. So this distance is taken as image distance v. Fine. Now for the first reading of object distance, we have already explained in the principle itself. To get the real and inverted image, we must keep the object distance more than a focal length. The approximate focal length of this lens is around 20 centimeter. Therefore, I will keep the object distance at 32 centimeter for the first reading. Okay. Now you can observe from the plane of this object pin, the position of the scale is at 0 centimeter. Now to the center of the lens, the distance, the position is 32 centimeter. Therefore, from plane of the object to the lens, the distance is 32 centimeter. Okay. Now you can observe the image is going to form on the screen, but the image is not clear. So we have to move the screen. We have to move the screen in order to get the clear image. Okay. Let me move the screen in the backward direction. Now you can see the image of that object is formed at the screen. Now let us look at the image distance from the center of this lens to the front surface of the screen. Let us find out this. Now from the center of the lens, it is 0 centimeter. Now at the screen, at the front surface of the screen, the position is 60.5 centimeter. Therefore, the image distance is 60.5 centimeter for the first object distance. Let us tabulate this. So for the first trial, the object distance is 32 centimeter and the image distance is 60.5 centimeter. Okay. Next, we will move on to the next trial. Now we have to increase the object distance to 34 centimeter. For the second trial, the object distance is 34 centimeter. Let's find out the image distance for this. Now for the second trial, the object distance is 34 centimeter. Now let us look at the image distance. I will move the screen to get the clear image of this. Now I am getting the clear image of this object. Let us find out the image distance from center of the lens to the screen. The distance is 56 centimeters. Let me tabulate this. The object distance is 34 centimeter and this is 56.0 centimeter. Now the third trial, let us increase the object distance further 2 centimeter. Now the object distance is 36 centimeter. Let's find out the image distance. Let's form an image now. Yes. So here we are getting the clear image of the object. Let's find out the image distance. So image distance I am getting here is 51 centimeter. Let us tabulate this. For object distance of 36 centimeter, image distance is 51 centimeter. Next, we will move on to the next trial. Increase the object distance to 38 centimeter. Let us form an image. Now the object distance is 38 centimeter. Let's find out the image distance. The image distance is 47 centimeter. Object distance of 38 centimeter. Image distance is 47 centimeters. Next, fifth trial. Object distance is 40 centimeters. The image distance is 44 centimeter. Next trial. Object distance is 42 centimeter. Let's find out the image distance. Image distance is 42 centimeter again. So for the object distance of 42 centimeter, the image distance is found to be 42 centimeter. So here we have got the object distance and the image distance which are equal. Okay. Therefore, after this, what we need to do is, so as we are using the symmetrical lens, if we consider these image distances as object distance, the corresponding object distances will become the image distance. You can verify this practically. So let me write these distances in the object distance column and the corresponding values of object distance in the image distance column. Let me write it. Okay, fine. So we have got the values of object distance in one column and image distance on another column. Now what we need to do is, we need to plot a graph of this image distance along the y-axis and the object distance along the x-axis. So when we plot this graph, we will obtain a curve. Using that curve, we can calculate the focal length of the given convex lens. Okay, let's do that. These are the readings what we have obtained from the experiment. The object distance u in centimeter and this is image distance v in centimeter. Now we have to plot a graph of object distance versus image distance in order to get the focal length of the given lens. Let's plot it. And one more thing is that the object distance is measured to the left of the lens. That is why these readings will be plotted along the negative x-axis, and image distance is measured towards the right side of the lens. Therefore, according to the sign convention, this will be plotted along the positive y-axis. Let us plot the graph now. Well, you can see here the object distance u in centimeter is plotted along the negative x-axis, and image distance v is plotted along the positive y-axis. First, let us understand the scale of the graph. Along x-axis, each centimeter is considered as 5 centimeter. Okay, x-axis is 1 centimeter is equal to 5 centimeter. So this is 5, 10, 15, 20 likewise. And along the y-axis, again each centimeter is considered as 5 centimeter. So y-axis is 1 centimeter is equal to 5 centimeter. Therefore, this is 5, 10, 15, 20 likewise. In both the axes, we have considered the same scale. Now, let's plot for these readings. The first reading is this. For the object distance of 32 centimeter, image distance is 60.5. So, here we have 30. So, the next second division is 31. And this division is 32. So, for 32, it is 60.5. So this is 60, and the next division is 60.5. So we have plotted the first reading now. Next, for the second reading, the object distance is 34 centimeter and corresponding image distance is 56 centimeters. So this is 34 centimeter. For this, the image distance is 56 centimeter. Here it is. Next, similarly, the third one, for 36 centimeter, image distance is 51 centimeter. Let's continue. For 38 centimeters, image distance is 47. This is a point. Next, for the object distance of 40 centimeter, image distance is 44. This is a point. Next, here we are getting the object distance as 42 centimeter and also image distance is equal to 42 centimeter. This is a point. For 44 centimeter of object distance, image distance is 40. This is a point. Similarly, for 47, it is 38. This is the point. Next, for 51 centimeter, 36 centimeter, this is a point. 56 centimeter of object distance, 34.0 centimeter is the image distance. Next, finally, for 60.5 centimeter of object distance, 32 centimeter is the image distance. Okay, so we have plotted all the points now. Now we have to draw a curve using these points. We have to draw a smooth curve from this point to here. Let's plot it. Yes, so this is a curve what we have obtained. Now we have to draw a bisector at a point where we got the object distance and image distance are same. Yes, so this is a bisector drawn to a point where we get the object distance and image distance are same. Now let me draw a perpendicular to the y-axis from this point. This is a line and this point is A. And similarly, let us draw another line which is perpendicular to the x-axis from this point. This is a line. Now from here to here the distance is OA, and from here to here the distance is OB. So OA is equal to 42 centimeter, correct? This is 42 centimeter, and OB is also equal to 42 centimeter, and this angle is equal to 45 degree as this is bisecting the center of the curve. I have got the value of OA and I have got the value of OB. The OA is equal to 2 times the focal length. OB is also equal to the 2 times the focal length. So if I do OA plus OB, we will be getting 4F, and if I want F, I can divide it by 4. Now let us move on to the calculations part. This is the calculation. Focal length of the convex lenses, F is equal to OA plus OB by 4. As I told you, OA is equal to 2F, OB is also 2F. So totally it becomes 4f. So if I divide it by 4, we'll get the focal length. We know that the length OA is 42 centimeter. The length OB is also 42 centimeter. So 42 plus 42 centimeter. If I add these two, we'll get 84 centimeter. 84 divided by 4 is equal to 21 centimeter. Therefore, the focal length of a given lens is 21.0 centimeter. This is the value we got. Let us move on to the last part of the experiment, that is writing the result. This is the result we got. The focal length of the given convex lens f is equal to 21.0 centimeter. If you write this in SI unit, you will convert this into meter. 21.0 into 10 to the power of minus 2 meter. Okay, so this is the end of the experiment. Well, in this experiment, we find the value of focal length of a given convex lens by plotting a graph of object distance versus image distance. Okay, that's all for this session. Thank you.